Solaris RBAC and the process rights management, so fine-grained privileges. Some of the reliability availability features from SMF, that one will be fairly short, and then also audit accountability. Now, this is all in the context of a service that you're trying to protect. And what this service is really completely up to you. And everyone has their favorite mail server, DNS server, web server, or business application that they're trying to protect. We applied this to, from our point of view, an interesting case study, namely the Oracle database. And I couldn't think of a clever joke at this point, but you sort of get the drifts on Oracle. Anyway, the first system we built up was actually on a Spark server, so a 5220, and that was a little heavy to lug around. So we redid that in Open Solaris here on this laptop. So the point is that it's really working in both environments, and the features that I'm demonstrating, although I'm doing it here on Open Solaris, work really one-to-one on Solaris 10, Update 7, and forward as well. So the initial deployment was on Solaris 10 Update 7, and what's on this laptop here, it's actually a really nice case study, and you can play with it later, ask questions during the demo time from 5 to 6 as well. There is a dual installation here inside of Solaris using the boot environments that are new in Open Solaris. You can basically boot into Open Solaris build 125 here, and you have an alternate boot environment where you boot into the same system but with trusted extensions enabled. And it shares a lot of the file systems between those two systems. In one of them, you have labeling and multi-level security and mandatory access control enabled. In the other one, you're more in the traditional, your familiar Solaris environment. And the particular service that we're securing here is the Oracle Database 10G Release 2. That hasn't actually officially been released on Open Solaris, so that was a bit of a hack for us to get that working. But because we started with that service on the other systems, we wanted to get it working on here as well. Good. So let's first focus on OS virtualization containers, and it's very nice for me that I'm following Darren's talk because I don't have to explain all the basic background anymore. I can assume now you know what Solaris containers, OS virtualization are, and what the main benefits are. But a few I still wanted to highlight here, and that is that, well, first off, it's a very lightweight virtualization technology. And you can actually have, with OS virtualization, we close what's called the semantic gap. So in typical hypervisor-based virtualization, if you try to examine what's happening in a particular environment, you cannot really look deep into the data structures of that environment. You can only observe things like memory pages, interrupts at the hypervisor layer. So you don't actually have information, high-level semantic information of what's happening. Whereas with Solaris containers, you have that information. If you're sitting in the global zone and you have access to memory pages or processes or data structures of the non-global zones, you know what's actually happening. You can use all the existing tools of looking at which processes are running, who do they belong to, which ports are open, which connections exist, and whatnot. So this is a big benefit here of the OS virtualization architecture. With respect to containers themselves, they're mostly a contained environment where everything that is inside stays inside and cannot break out unless it goes through a network port, which is properly authorized. But nothing is shared across different zones. So looking at a picture here, this is really how you can imagine it. You have on the very low end really the hardware or a hypervisor with the physical NICs or virtualized NICs. In this environment, we can assume it's the hardware. The OS sitting on top of it, and then a user space above the OS that runs your service. And for the demos throughout this talk here, I'm going to run most things within this host O zone, so this stands for Oracle zone, and as the user Oracle. Actually, it's not quite like that, because we're not running it on the physical machine, but we're running it all inside an OS container, inside a virtualized environment. So you have a little more plumbing underneath that, again, I don't have to explain now because Sunay Tripathi is coming, giving a talk later this afternoon, and he's going to explain how the magic plumbing down here works in Open Solaris with Crossbow. But the service still runs within that virtualized environment, and to the service it just feels like a regular Solaris machine. It's not actually running on behalf of a user oracle, but it's running on behalf of a role oracle. So this is where the role-based access control comes in now. So the person wanting to administer this service now would log in as themselves, and in our case this is always the user JDO, John Demo, slightly misspelled. And he would assume the role oracle and then run everything as the oracle user. Now in the global zone here, everything that's green basically, again you would log in as another user and assume the root role if you need to do introspection, for example, or some higher level system administration. So for example, zone administration can only be done from outside the zone, from the global zone. So this is sort of the picture that you should keep in the back of your mind now. Good, let's switch to the first demo to just look at sort of the environment that we have here. So this is now the desktop for Open Solaris. I moved the various different panel bars to the bottom. So you already get used to where they're placed later when Trusted Extensions is running because the trusted stripe will be on top. So if we look at the zone administration, look at which zones are installed and running here, we basically have two zones. The global zone, always ID 0. It's currently running. Its root is at the path /. So in the root, it's a native brand, and it's a shared IP stack. This is also something that Darren mentioned earlier, that zones come exclusive or shared IP type. And the first zone here, O zone, the one that's the interesting one for this particular demo, that is an exclusive IP type zone. So that means a lot of the IP administration, IP stack administration that you care about is actually delegated to that particular zone. And then the root of that zone is mounted underneath zone/O zone. So let me log into that zone now as JDO. And once I've logged in, here we go. If I now type zone name, we're inside this zone. It's a different IP address than what we had outside. And as I said, the administration of the IP stack is now actually delegated to this particular zone. So let's go back to the slides and continue here on slide 9. What are sort of the benefits of the process security that we have in Solaris? Well, the processes that are running inside zones, they can't really escape the zones. There is a very strong process and data separation. File systems are mounted inside ones, they belong to one zone. They can be shared across zones to things like NFS, or mounted from the outside. But Glenn will go into detail here what actually the rules are when you also add on the multi-level security and a hierarchical relationship between what's allowed to be visible, what's allowed to be shared, and in which fashion. The power of the root account is really greatly reduced in this environment. As a matter of fact, in this environment here, we don't even have a root account or root role enabled anymore inside the zone. So any administration that you would want to do for the zone, you can only get to from the outside, from the global zone with a zlogin to get the console. So that means if you give regular users access to that particular zone, the amount of damage they could possibly do to the zone is very, very small because no one can run with elevated privileges whatsoever. In addition to the limitation of which privileges individual processes in the zone can have in the first place. So you can't, for example, introduce new kernel modules because you're in a zone. You can't modify the kernel in any way. What's also interesting is that zones have their own service management facility, so per zone. That means we can reduce the attack surface for individual zones greatly by running really only exactly the services that we want to run inside this zone. So in zone O-zone, hardly any service is running. Really only the Oracle database ports are open, the listener in the database that we care about. Good. Let's look at the file system configuration just briefly. And again, Glenn will go into more detail here when he explains sort of the parallel setup of the two systems. This picture here shows you what the file system setup looks like for this particular machine. So you have, all of this is CFS, right? So you have the root file system for this particular boot environment under /root, and it's called OS-125 in comparison to TX-125, which will be the trusted installation. There are a whole bunch of directories, data sets that are actually shared across the two systems. The first one here is the export home, with the various different roles that we actually care about in the root file system. So here we have an auditor role in the root file system, in the global zone, and we have a user that can log in. In addition to that, we also have user ID Schuba and G. Faden for administering the system. And for the zones, we have 3 directories here. The first 2, again, one for the user and one for the role. And the third one is a read-only service data set where we installed the binaries that are part of the Oracle installation that get mounted into the zone in a read-only fashion through the loopback file system. So this is a very strong statement because that means that no one inside the zone can actually modify the binaries that are being used for serving up the service, right? And we're doing this not only with the directory and the binaries that run the service, but you could do this for any part of the system, right? Anything in user bin can be loopback mounted, read-only, or configuration files. And you'll see some examples throughout the talk here. The one piece I haven't mentioned yet is the zone's O-zone root. So the non-global zone also has a root directory, right? And if you add additional boot environments to a system, you need to keep in sync which root environment exists in the non-global zones with the one that exists in the global zone. And this is the mechanism to do that. It's not actually exposed to the user in detail. As you create a new boot environment, it automatically creates a new zone boot environment for you as well and keeps them in sync. So the next page here, if I just switch back and forth quickly between the two, you see the difference highlighted. Also shows where the only differences are for the second boot environment. So you have now a trusted 125 boot environment for the root file system as well as one for the individual zone. Good. So if we look at this on the screen here, and I'll pipe this into more so you actually see it in detail. Here's the R pool is the one global pool that exists on the system. Then these 3 are the 3 boot environments we have. So the Open Solaris one is the default one that gets installed as you put the CD in the first place. Then the next 2 are the ones that I already explained. So OS-125, which is running right now, and then TX-125. Then underneath that, the export home file systems for auditor. So this is the role we will assume to actually execute the introspection and look at auditing output. Then G. Faden, Schuba, and J-Do, our demo user. And finally, the various different file systems that belong to the non-global zone. So first, the boot environments for the non-global zone, and then the various different home directories that we need. So for the users and for the role and for the read-only loopback mount. Let's also look at the zone configuration for the zone. And let's see how the zone is configured and how these various different file systems are mounted into this contained environment. So here you see the zone name, the zone path, the iPackage brand, and Glenn will go into details there once this switches to something else, what that implies. Excuse me. Everyone awake again? Good. Then limit privileges is the default. Exclusive IP type, so IP administration is delegated to the zone. And then here comes the first funky one. So FS always stands for file system. And what's mounted here is not really a directory. So traditionally we look at directories being mounted on top of mount points, right? Well, this is a file name that's mounted on top of a file name. So that's kind of interesting. Let's look at the one that actually is used throughout the demo, and that's the configuration for auditing. So we have a configuration set up for auditing in the global zone that's in the file etc security audit user, and that is mounted into the zone into the same path. It's a loopback file system mount, and it's read-only. That means inside the zone, no one can modify the configuration for auditing, even if there was a root account or a root role in the user that could get to this. Because it's loopback mounted and read-only over that existing file, it can no longer be modified from within the zone. That means the zone is subject to auditing if it likes it or not. And there's nothing the zone can do about it. And then further down, you see more file system entries. Here is the one that lists the read-only loopback mount for the Oracle bin directory. And this mounts it not into the same place, but it mounts it into the 10G release 2 bin directory inside the Oracle installation, just where it would expect it. Good, let's go back to the slides. So I'm on slide, let's see, 14, 15 now. So let's jump into least privilege. User rights management was already explained by Darren in detail. What we're focusing on here in this presentation are really the two on the bottom here. So the one in the middle, the audit review, slide 17, and Oracle Administrator. So you can think of this as a number of keys that to a super user, all of them would be available. But in order to sort of fulfill the role of an internal auditor or the role of an administrator for that particular service, you just need a subset of these keys, right? So the user rights management really allows you to administer this assignment, this association with which rights are associated with which user. So what we've done here is we've turned the Oracle account into a role. And in Solaris, a role is really a first-class citizen. The only difference is that into roles you cannot log in directly. You would use role-add or some of the GUIs to administer that. And then the role is assigned to specific users, in this case, the user JDO. So the way this would normally work is you log in as the user and then subsequently assume the role of that role that you want to assume, namely Oracle. So you use SU to assume the role. Everything that you do then as Oracle is audited. And we use the same mechanism in the global zone for the auditor role. So here's the setup pictures for both the non-global zone and for the global zone. So we have a user JDO, and I added add ozone here so to highlight where it's actually happening. This is in the non-global zone. So this user can assume the role Oracle, and the role Oracle is associated now with a rights profile. And the rights profile that we introduced is called Oracle Management. Associated with that are now two different sets of things. The first are the executables that this particular rights profile is allowed to execute. So you see things like sbin star, user bin star. But the more interesting ones for this particular rights profile are the binaries in Oracle 10.2 bin with the effective user ID of Oracle. We added that on to get the auditing output just right. So that's just an aside. And then also the authorizations. So these authorizations can either be programmatically checked by source code with the check auth adder call, but that would require access to the source code and modification of the source code, which you can't really assume in all cases. So the other primary consumer of authorizations is SMF. So the Oracle services that we're starting here are actually administered through SMF. So SMF now checks through the SMF manifest if the user that wants to start this particular service has these action authorizations. Or if you want to administer the configuration, if the user has the value authorizations for these services. So we introduced one for the database and one for the listener. Now, if you did this, properly for actually shipping it with the Oracle database, you would go much more fine-grained. But this is the main purpose here is really to illustrate the mechanism. Yeah, Brian?
Excuse me, that could be bypassed, right? If I were to start Oracle outside of SMF,
Whoops.
then it would be ignoring the authorizations that you set up.
That's not necessarily possible because, so in the SMF profile, one of the things that you set up are actually the privileges that this particular service gets. And SMF runs on behalf of root, but assigns the effective user ID and assigns the role based on what's in the SMF profile. So, and I will demo this actually just slightly differently later. The Oracle role has fewer privileges than you need for running the Oracle database. Okay? So it will both run under the same user ID Oracle, but the processes that belong to the database or the listener run with more privileges than the actual user has. Good, so let's go back to the demo and let's see how this looks in reality. So page 20, and here I need to go to this window. So I'm already in the zone O zone here. My ID is currently JDO. And if I look at the roles that I have one role assigned, namely the Oracle role. And if I look at the profiles that are associated with Oracle, it's just what you saw on the previous screen, right? So you have basically these directories with the binaries that you're allowed to execute here. And if I look at the authorizations for the role Oracle here, the authorizations. So let's just do that here as well. Let's go into the global zone. So here zone name is global, and I'm logged in as JDO. And if I look at my profiles, I have actually far more profiles. Hang on, I wanted to look at the profiles for auditor. Sorry about that. Auditor. The roles that I'm allowed to assume here are Oracle and auditor in the global zone. So it's different in the global zone from the non-global zone. So this shows you already that the namespace management is zone specific. So you can have different namespaces and assignments here in individual zones versus the global zones. And they can even be different across different zones. So here the auditor is allowed to do audit management, control, and zone management. Good. Let's go back to the slides. So this, the next part that I wanted to show is the process rights management. And Darren, again, already explained that in detail, so I don't have to go into details anymore. But what I'm showing here with the demo is basically which rights, which privileges are assigned to the various different processes as you're running. So here I'm going to show now basically the answer to your question, Brian, from a minute ago. So let's go into the demo here for slide number 25. And I'm back in the non-global zone. So first I'm going to assume the Oracle role. Good. Now we're logged in under role Oracle. So ID, Oracle, has its own user ID. And let's look at which privileges are assigned by default to the user Oracle. And we did this modification on a per user basis. There was a discussion about that in one of the talks this morning. You can set that for the system. You can set it for individual users. It's really a scalability question how you want to assign it. Here we just assigned it on a per user basis, and we changed the default set of privileges for that user. So traditionally for a user or a role, it would be basic. But we're taking one privilege away here, namely the proc info privilege. That means if I do a PS, I can only see my own privileges now as role oracle. I cannot see anyone else's anymore. Okay? And so let's do that. If I do a ppriv on the current shell, the effective, inheritable, and permitted sets are all basic without proc info. And the limit set, this is a bit hard to parse, but this is basically the zone limited privilege set. So it's not all privileges, but what's available to the zone as a limit set. All right, that's nice. So if I do a PS, I really only see Oracle processes. I see nothing root. I see nothing from JDO, who is currently on this zone. And it turns out most programs actually don't need to look at other programs' process status. So it's actually fairly safe to take that away from a process. But if we now look at the process table and look for one particular process that's running on here on behalf of the Oracle database, namely the system monitor, this runs as user Oracle. So here's the user ID, 2510. If I now look at the, 2510, this process, the effective set is basic. So it's slightly more privileged than what I can do as user Oracle. Okay? That means I have no control of this process anymore, although I'm the owner of it in some sense. Well, no control is not true. We didn't take the proc session privilege away. I can still signal it. I can kill the process, actually. But I cannot list any information about it because we took the proc info away. So if I do, for example, a truss on this particular process ID, 2510, I get a permission denied, although I'm the owner. So here's an example where a process was started through SMF with more privileges than the user has, right? And for the process to be successful, it might need all these privileges. So I, as the user Oracle, cannot run this process just out of the bin directory. Good. Let's go back to the slides and look at the SMF. This statement here, effective set of Oracle shell is not equal to the effective set of the system monitor, is what I just showed, what I just explained. So I don't have to go into details here anymore. But what I did want to highlight again is that the services for Oracle now are SMF managed. And the manifest for that defines what exactly, how exactly this particular process is run. So if I look, for example, at the output of which services are currently running, just for Oracle, we see that both the database and the listener are online and have been running since, I guess I'm on California time on this box, since an hour ago or so, right? And if we look at the configuration, service config, export, for example, for the database, you see the manifest for that particular system. So let me go back to the slides. Oops, I quit. And explain some of this in a little more detail. So the SMF manifest has really a number of different sections, namely dealing with in which environment does this particular service run, which kind of authorizations does it need to run properly to either start or stop, or to modify the configuration. How do you actually start or stop the service? So this is the subset of this manifest that I just displayed on the screen that says something about which authorizations are necessary to run or modify the configuration of this service. So what you see in here is really the use. Oops, this highlights everything, not just what I wanted to highlight. Okay, can't do that. So if you look into the fourth line of this output here, where it says value equal, this is the string that needs to be part of your authorizations for that particular role in order to do any actions on this service, namely starting and stopping the service. If you look a few lines down, you see the managed database value, again, as a value authorization. That means if you want to make any modifications that have to do with the configuration for this particular service that are supposed to be persistent across reboots, you need to have, again, that particular authorization. So the next section that I want to show is the environment in which this service starts and runs. So here there are a number of environment variables towards the bottom: TNS admin, SID, Oracle Home, Oracle Base, library path, and so on. So these are typically the kind of environment variables that you would expect to have set in a shell script that starts the service, for example. And further up, you see the method credentials. So here you see on behalf of which user this is supposed to run, on behalf of which group, then what the limit privileges are, and what the default privileges are. So the word basic here, because we wrote basic here, that's why in the ppriv output earlier for the Oracle database process, we saw the effective set to be basic and not basic without proc info. Then you can define dependencies and instances in the manifest. So here, one of the main dependencies we have is that the milestone multi-user has to be reached. Again, you could add a dependency here that says, oh, for this service to be up, you need to, the IP filter service needs to be up with the following configuration that would, for example, tighten the network configuration down to the point where only the one service port for the listener inbound is open. Okay. Another advantage of SMF. Yeah, Brian?
Does Oracle provide us manifest to modify, or do you create the manifest?
Which one?
Does Oracle provide an SMF manifest that you modify?
Yeah, we're not past changing control yet. No, they don't. So we found actually, no, they don't do that yet. We found the majority of this. Oracle doesn't. There are lots of services who do. And the majority of this SMF manifest we actually found on the web on a blog page from someone else. So we modified it obviously to accommodate some of the changes we wanted to make. But yeah, that's one of the things we hope to be working on with them to make their services really Solaris ready. And then the final section I want to talk about here is are the start and stop methods. So this just shows you how to, if you do the SMF enable or disable, what actually gets executed against the Oracle database. Good. Finally, audit. So the portion I want to show here is really a very crude, basic way of doing introspection from the global zone, something I mentioned at the very beginning of the talk. So here you have the same picture as before, the Oracle service running on behalf of role Oracle in the non-global zone. And in the global zone, we're running the fancily termed introspection engine. All it really is a really dumb little shell script that says, well, forever display new audit trail entries in Firefox and then sleep for 10 seconds, okay? So it's very basic. But what was interesting about it is, well, first off, that you can do this without the non-global zone being able to modify it in any way. You actually get very high-level information about what's being audited. It's real-time, or you could capture it to the file system, or you could feed it offsite for later analysis if you wanted to. Yeah, let's run that as a demo, and then you see what's happening. So let me go back to the demo screen here. So first, I need to assume the auditor role, because I hadn't done that yet. So now I'm on the zone name. I'm on the global zone. My current ID is auditor, and I need to set the display to... Okay. And I'm going to run that shell script that we call show. I timed it right, I hope. There you go. So here is Firefox just popped up. And I quickly moved over to the other screen. So in this screen now, we share the same screen between output from two different applications that run in two different zones, right? The shell here runs in O zone. The Firefox instance runs in the global zone. So inside the non-global zone now, I start the profile shell because we set up the auditing to only audit what's happening in the profile shell so we wouldn't get overwhelmed with output. So everything that I type in here now is being audited. So let's do the grep on Oracle, basically the command we did earlier. So within 10 seconds, hopefully, there's the output. The write screen updates and shows everything that happened since we started auditing. So I just scroll to the bottom. And what you're seeing here is the audit ID JDO. So this is the actual user that had logged in. Then the real user ID, Oracle. So this is the role that's currently assumed. Just executed inside this path, export home Oracle, the command user bin services with the argument -a at the following time and whatnot. And all of that was piped into grep, right? So this is very powerful that you can observe that from the outside without any modification on the inside. And it's all, out of the box and just a minimal amount of configuration necessary here. Good. That concludes the talk.